Hello, calculus students. My intention with this video is to take you through an example from section 2.1 as a way of actually for me testing out a new document camera I have, and also to check with you whether this kind of video would be something that you would find helpful. So I definitely would appreciate your feedback. So this is an example asking about average velocity. And in section 2.1, average velocity is an important concept to explain why we are interested in limits. Average velocity if you have a position function that we call S, the average velocity over the interval from A to B is equal to S of B minus S of A over B minus A. Okay. So we're finding a slope, okay? And this is something that all of you taking this course have seen in some previous course. An algebra course, is often where you learn about the slope of a line by doing change in y over change in x. That's what this is really asking us to do here. We're given a position function. If we look at the change in position over change in time, that's average velocity. And for this particular problem, they're asking us to do this over various intervals with the position function that they gave us. So for this one, part A, we're looking for S of 3 minus S of 0 over 3 minus 0. And what we're going to do in this part, and actually we'll do something similar in the other parts, is to write out the expression and simplify it. And in this case, we'll get a number when we do that. So now we want to pay attention to our position function that they gave us here. And S of 3 would just be that function when we substitute in the value 3 for t. Okay, I'm going to put parentheses around that. And then S of 0 would be that function evaluated at 0. Okay. And then the whole thing over 3 minus 0. Okay. Now, the expression we have here simplifies to 65.9 minus 20 over 3, which is equal to 15.3 when we simplify that. Let me say something before moving on to the next part here. In this particular problem, there were no units given, which is a little bit unusual because we are talking about position and time. So often, had we been given units, we would see an answer here that might be in feet per second. So if this was in feet and time is in seconds, this would be in feet per second. Okay. Just happened that in this problem they didn't include units with the statement of the problem. All right, so for the interval from 0 to 2, this is going to work in a very similar way. We'll have S of 2 minus S of 0 over 2 minus 0. Okay. And let me write out the full expression one more time for this one. So we'd have negative 4.9. We're evaluating this at 2. So negative 4.9 times 2 squared times plus 30 times 2 plus 20. That's the S of 2. S of 0 is just 20. That's when we evaluate at 0. Let me write out the entire thing, just so that it's clear where this is coming from. Okay. Over 2 minus 0. So this is 60.4 minus 20 over 2 minus 0. And that all simplifies to 20.2. The units would be the same as the units for the previous part. Okay. And it's going to work much the same way for the next one, right? That would be S of 1 minus S of 0 over 1 minus 0. Okay. And I encourage you with this part, and actually any of this problem, you know, as you watch through it, or maybe you watch through it a second time, you know, kind of pause the video and, you know, try to work out the expression on your own. And I think that's going to help you, you know, when you are doing this on other examples. S of 1, in this case, let me just get right to the numerical value. S of 1 is 45.1. S of 0 we know is 20. This would be over 1 minus 0. And this simplifies to 25.1 feet per second. Let me, before I move on, there is one more part of this problem. Before I move on to that, let me just kind of take a step back and talk about what we're actually calculating here. Okay, so we have this object that's moving. The first part of this problem was asking us to find the average velocity over the time period from 0 to 3 seconds. So we're figuring out, on average, how fast is this object moving during that 3-second interval. The next part has us looking at how fast, on average, is this object moving. That is, what's the average velocity over the 2-second interval from 0 to 2. And then in part C, it's the 1-second interval from 0 to 1. If we had enough information to continue this process, or if they asked us to continue this process, I should say, because we have the function for any value of t we want, we could narrow down this interval even further and kind of push that right end of the interval closer and closer to 0. And that really is the heart of the idea of a limit, is that, you know, in this context, we are shrinking the interval down as a way of understanding average velocity over smaller and smaller intervals. And in the long run, that should give us information about the instantaneous velocity at 0 itself. Now, this problem doesn't go that far, but that's how this ties in with sort of the overall subject of section 2.1. Okay, now the last part of the problem actually kind of gets at what I was talking about there with shrinking the interval down even further. And what this does, which may seem a little bit unusual, is this asks about the interval from 0 to h. So instead of a specific number, they're just giving us some value of h, and it says where h is a positive real number. What's useful about this is that once we have a simplified expression for this, then we have this something that would work for any h that we want, and we can just plug right into that expression. The thing to understand, though, is unlike the other parts of this problem, we are going to have an answer that will have h in it. Okay, so let me show you what I mean. So just like before, we'll have change in y over change in x, or the s of b minus s of a over b minus a. But in this case, the b, the right end of the interval, is h. Okay, so when we plug into that, we're plugging in h. So negative 4.9h squared plus 30h plus 20. We know s of 0 is 20. So that's our expression that we need to simplify. Now notice we've got plus 20 minus 20. And there is one more thing we can do in terms of simplifying our answer, that we should do to simplify our answer, which is h is a factor of the numerator. So if we factor out an h, then we can cancel a factor of h with the denominator with the factor of h on the numerator. And that gives us our answer, negative 4.9h plus 30. And again, the units would be feet per second. And one thing that you might do is take a look back at our previous answers, and you'll see that this answer that we get here is consistent with those. That is, if we plugged in the right-hand endpoint as h, we would get those numerical answers we got for parts A, B, and C. So that's the end of this particular example. Again, I'd be interested in your feedback if you found this useful, if you'd like to see more examples like this from other sections, and have a great day. Take care.